Hey there, Seahawks, it's Miss Adams, and in this video we're going to go over randomness, probability, and simulation. Alright, so the law of large numbers states, if you repeat an experiment independently a large number of times and average the results, what you obtain should be close to the expected value. If you do the experiment many times, the experimental probability will equal the theoretical probability, okay, or be very close. So we're going to use an example of a simulation of flipping a coin. A simulation is a way to model random events, such as our simulated outcomes closely match real-world outcomes. All right, so here we are. The probability of getting a heads is 50%. Number of tosses, we're going to start with just one. I'm showing you the true probability at 50%. And so if I toss the coin, I got tails, so my probability is at 0 right now. If I flip again, now I got a head, so I'm at 1 out of 2 were heads. If I toss again, I got tails. Now my probability is down to 33.3%. Again, I got a head, so I'm back up to 50. I got a heads again, so my percent 60. Another heads. So I'm kind of on this getting a lot of heads in a row, so my probability is increasing. All right, now let's go ahead and change this to like 5 times. Okay, so each time I'm going to let it run, do 5. This time let's do 50. Okay, so as this increases, it should be getting closer and closer to the true proportion or the true probability. So see how far off it was at the beginning, and now it's getting really close to that line. Okay, so this is just doing a simulation. So we could actually flip the coin and record how many heads, how many tails we got, but we'll just let the computer do it for us. All right, another way to do a simulation is to use a table of random digits. So a cereal company is giving away prizes in each box, and they advertise, collect all 6 prizes. Each box of cereal has 1 prize, and each prize is equally likely to appear in any given box. Run a simulation to estimate how many boxes will need to be purchased on average to collect all 6 prizes. All right, so we're going to say let the numbers 1 through 6 be a prize. I'm going to ignore the numbers 0 and then 7 through 9. All right, I'm going to stop once all 6 prizes are collected. My response variable is going to be the number of boxes it takes to get all 6 prizes. That's what I'm going to be measuring. And I'm going to do as many trials as I can. So 6, that's a prize. 1, that's a prize. 4, that's a prize. 2, that's a prize. 4, that's a repeat, so I'm putting a little R above it. 2, another repeat. 0, I'm ignoring, so I'm just going to scribble it out as if that number was not even in here. 4 is a repeat. 1's a repeat. 9, I'm ignoring. 8, I'm ignoring. 6 is a repeat. 5, I got 5, so I have 1, 2, 3, 4, 5. Let's see, I have 1, 2, I need 3. So I'm going to keep going until I get a 3. 4 and 6 are repeats. 0s, I'm ignoring. 5's another repeat. 1's another repeat. 7 is ignore. 9 is ignore. 0 is ignore. 2 is a repeat. And finally, I get a 3. So I'm going to draw a line there. I'm stopping that trial. And I'm going to count how many boxes did I have to buy. Okay, so anything that has a check or an R means I bought that box and I got a prize. Some of them were brand new prizes. Some of them were repeat prizes. Okay, but that took 16 cereal boxes for me to get all 6 prizes. All right, I'm going to go again using the rest of my random numbers. I'm going to start right after my line. 2, that's a prize. 2, that's a repeat. 7, ignore. 9, ignore. 9, ignore. 3 is a new prize. 0, ignore. 4 is a new prize. 9, ignore. 5 is a new prize. 2 is a repeat. 6 is a new prize. 6 is a repeat. 7, ignore. 1 is a new prize. And that's all 6 of them. So that time it only took 9 cereal boxes. All right, and I think I have enough to do a whole nother trial. So 2 is a new prize. 5 is a new prize. 0, ignore. 3 is a new prize. 4 is a new prize. 9, I'm ignoring. 7, I'm ignoring. 1's a new prize. The next one's a repeat. 4 is a repeat. 6 is a new prize, and that's all 6 of the prizes. That time, it only took 8 cereal boxes. Okay, so I can kind of calculate the average here. So if I do 16 plus 9 plus 8 divided by 3 trials, okay, that gives me 33 out of 3, which is 11. So on average, I would expect to have to buy 11 cereal boxes so that I can get all 6 prizes. All right, interpreting simulated results. The probability that Xavier succeeds at any given free throw is 70%. He was curious how many free throws he can expect to make in a sample of 15 free throws. He simulated 20 samples of 15 free throws, where each free throw had a 70% probability of being successful. Xavier counted how many free throws were successful in each simulated sample. Here are his results. So he shot 15 baskets. Some of them were makes, some of them were misses, and he did that 20 times. So there's 20 sets of 15, and we counted how many actually made it, how many were successes. So use his results to estimate the probability that he makes more than 10 free throws in a sample of 15 free throws. So more than 10, okay, would be anything above 10. I circled that one point just to say that that one circled point comes from one trial of 15 shots, and he made 13 out of the 15 shots. That's what that circled one is saying. All right, so there was 13 of them that were greater than 10 out of 20 total shots that or 20 total samples of 15 shots that he did, which is about 43.3%. All right, go Seahawks.